Hey Ali, I have set up a calculator here that calculates percent of data points lost on each end. I want to illustrate how that works. So say that we go down into the PNAS social sciences section here, and then we find the first graph that has a relevant figure, and we click on that, and we get our PDF and go to figure 4. Here's figure 4. And say, so we need the bottom and the top of the y-axis range. I've sort of done this here in this column, but I'm just going to do it in this column just to redo it. So we go from 0 here at the bottom to, I figure about, that would be 5,000, 6,000, 7,000 would be here, so I figure 6,700 or so. And the value of the most worrisome, I guess, mean is this one right here. And I figure that's about 2,850, give or take. So we say 2,850. This is a mean, we think, our best guess. I'm just thinking of broadly, is this a mean or a median? And pretty much almost everything is probably going to be a mean of some sort or another. Even if it's a parameter, it's going to be the mean estimate of that parameter usually. So this is like basic type. Is it a percentile-based measure, or is it an estimating the mean like middle type of a measure? Okay, so span. So this is something you have already over here. I believe it's what type of confidence interval is it? It was there. I'm sure it's there somewhere. Anyway, it's what type of confidence interval is it? So if it's a standard error, it would be a 68% confidence interval. In this case, it's an 80% confidence interval, so we can just put 0.80 and approximate confidence interval bottom. So I figure that's about 1. If that's 1,000, that's probably 1,200 or so. Approximate top, I figure is 6,150 at the n, assuming here that they're working in years. So I put years with question mark because I'm not super sure, but as best as we can tell, there'd be 6 years. 9, 10, 11, 12, 13, 14 would be 6 years. And so then we have a formula here, which will calculate the z for 1/2 of that confidence interval from the mean to basically it sort of does a heuristic where it starts in the middle of that, and well, actually, come to think of it, what it does is it takes this span, assuming that is 80% confidence interval. Then it says, what is 40% going to be? So that'll be that's the z distance that one has to go in a normal distribution to out in each direction to get a 40%, an 80% confidence interval. Not sure if that made any sense, but basically if we have an 80% confidence interval, and we know it's this large, then the question is, given normally distributed data, what is the z that we have to go out in each direction to create that confidence interval? So that's the z in one direction. This is the z in two directions. So that's the span. This is the number of z units that would span 80% of normal distribution. Then we can just truck through here, and that will automatically calculate what one standard error is. So if this is 80%, then roughly speaking, 68%, maybe it'll be something like that, and then one standard error would be something like that, and so one standard error is like 2,000 or so. So that's about one standard error. Then we do our calculation to go from standard error to the standard deviation. The standard error times the square root of the n. And then we can calculate we take the difference between the summary stat and the bottom, and we divide it by standard deviation to get that distance in z units. We do the same thing between the summary stat and the top. And then we do a simple z calculation where we say how much of the data should be missing off the bottom, given that different distance between the summary stat and the bottom in z units, and how much should be missing off the top. So let's see. So technically, there we go. As soon as we get to here, everything else is automated. There. So if we can provide, basically, if we can provide these things, let's see, that, and those things for whatever bar we decide we care about, then all those things will be calculated automatically. Again, this is assuming normal distributions. Clearly this is not a normal distribution here, but I think we can simplify life and assume that for present purposes. Also, it doesn't account for the fact that 0 is probably the lowest possible score, so it does show things going off the bottom. But I think, again, for present purposes, let's just ignore that, and we can take it into account later if we choose to. So really, I've talked through this, so it's taken a few minutes, but I think for many papers we should be able to find this, bottom, top, approximate value, the summary statistic, bottom and top of y-axis range summary statistic, the apparent approximate span, what type of confidence interval it is, the approximate bottom, the approximate top, and the n. I would say if we can find these things out within about 2, 3, 4 minutes, then we keep the paper. If we don't, then we don't bother with the paper for now. Also, I sort of like the idea of starting with social sciences and doing a few of those and seeing how things go, because that may end up being the center of what we do, and then maybe biological sciences next. Anyway, we can go back and forth to sort of we can chat about that further. But anyway, here's a fairly straightforward way of grabbing a few pieces of necessary information and calculating some useful stuff.